Okay. So we are starting with this topic of machines. We'll be doing numericals of that chapter today. These are some of the formulas that will be used in this exercise. Okay. These formulas cover both lever as well as pulley system. So there is the formula which is similar for both of them. Fine. So this is the first question. What we have for an operating water pump, the resistance is 480 Newton. So that will be termed as a load. So load will be 480 Newton and to overcome an effort of 70 Newton. So effort applied is 72 Newton. Now, if the distance of the fulcrum from the point where the resistance acts is equal to 0.2 meters, so that means this will be the load arm. Okay, find the distance of the fulcrum where the effort acts. So that means they are asking for the length of the effort arm. So here what we are using is by the principle of lever. You have load into load arm. Okay, load into load arm is equal to effort into effort arm. So here this is the load arm and they want us to find the effort arm. Okay, so this is 480 into 0.2, that will be 72 into effort arm. So therefore effort arm will be 480 into 0.2 upon 72, and the effort arm will be equal to 1.33 meters. This is the second question. A uniform plank of seesaw is 5 meter long and it is supported at its center. So therefore, if this is a 5 meter long seesaw, so this will be 0, this will be 2.5, and arm is equal to effort into effort arm. So that will be 40 into 1 is equal to 25 into x. So x will be 40 into 1 upon 25. 5 5s are and 5 8s are. So it will be 1.6 meters. So the answer that we have to write, the girl needs to sit 1.6 meters from the fulcrum on the other side. Okay, or you can say the right side. Yeah. A crowbar of length 120 meter has its fulcrum situated at a distance of 20 centimeter from the load. Calculate the mechanical advantage of the crowbar. Now, this is what I have told you when I was teaching you, that they will not tell you what kind of a lever it is. They have mentioned over here it's a crowbar, so you have to understand that it is class 1 lever. Okay, so in this one, the fulcrum lies in between. Now this is 0 and this is 120 centimeter. So suppose if you consider this as the load, okay, then this is the fulcrum, and that is the reason why over here the load arm is equal to 20 centimeter, and over here this is the effort arm will be 120 minus 20, that is 100 centimeter. Now we know they have asked for mechanical advantage, which is effort arm upon load arm, and that will be 100 upon 20. So mechanical. So a handle of a nutcracker is 16 centimeter long. Nutcracker means class 2 lever. So the load is over here. So this is 2 centimeter, and then you have a force of 4 kgf is applied. That means the effort is equal to 4 kgf. Okay, at its end. So that also is given at its end. Now, what weight if simply placed on the nut will crack it? So we have to find the load. Now again, we have load into load arm is equal to effort into effort arm. So this will be 2 and this will be 4 into 16. I hope you understand that because this is a 16 centimeter long nut. So this is 32 kgf will be the load of the nut. Now they are asking us that what load placed on the nut can crack it. So the answer is 32 kgf. So if there is this nut is there, okay, and if you put a load of 32 kgf, it will crack the nut. Now that we are doing it by just 4 kgf because we have this nutcracker over here. Now question number 5, an effort of 50 kgf is applied at the end of a lever of second order. So a class 2 lever load will be here. Here is the fulcrum and here will be the effort. Okay, so an effort of 50 kgf which supports a load of 750 kgf, such that the load is at a distance of 0.1 meter from the hinge. Okay, so this distance, which is the load arm, is 0.1 meter. Find the length of the lever. Means basically they are asking us to find the effort arm. So these all things are very crucial, because if a child doesn't know what is the meaning of second order lever, okay, then they will not be able to draw the diagram. Okay, so again, load into load arm is equal to effort into effort arm, and therefore what we have is 750 into 0.1 is equal to effort, that is 50 into effort arm. So that means 75 upon 50 is equal to the effort arm. 25 twos are 25 threes are, and the effort arm will be 1.5 meter. Okay, so the answer will be length of lever is 1.5 meters. A machine displaces a load of 125 kgf. So load is 125 kgf to a distance of 0.3 meters. So displacement of load is 0.3 meters. Then when an effort of 125, 12.5 sorry, kgf acts through a distance of 4 meters. Okay. What is the velocity ratio? What is the mechanical advantage and the efficiency? So velocity ratio is displacement of effort upon displacement of load. So that is 4 upon 0.3. That is 40 upon 3. That is 13.33. Okay. Mechanical advantage is load upon effort. That is 125 upon 12.5. That is 10. And the third thing is efficiency is MA upon VR into 100%. So that is 10. And this is 40 upon 3. So that will be 10 into 3 upon 40. And this will be 25. So this is 75%. Okay, so make sure you remember it displaces through a distance of 0.3 meter. So that means it should not be load arm. It is displacement of load. Calculate the velocity ratio, mechanical advantage, and efficiency of a machine which overcome a resistance of 800 Newton. So load is equal to 800 Newton through a distance. So this is 0.12 meter. When an effort is equal to 160 Newton through a distance of 0.72. So similar question. Velocity ratio is displacement of effort upon displacement of load. So 0.72, 0.2. So this is 6 R. And remember that they don't have unit. This is load upon effort. So this is 800 upon 160. So this will be 5. Okay, and efficiency is MA upon VR into 100. So 5 by 6 into 100. So that will be 500 upon 6. This should be 83.33%. Remember, we don't write it in fractions. We write it correct up to 2 decimal places. An effort of 500 Newton is applied through a distance of 0.5 meters on a machine. Okay, so effort is equal to 500 Newton. Displacement of effort is 0.5 meters, and efficiency is given as 90%. Okay, such that the resistance to overcome through a distance of 0.04. So therefore, displacement of load is 0.04 meter. And what we have to find is VR, MA, and the resistance. Okay. So looking at this information, obviously we can find the velocity ratio first. So this is 0.5, this is 0.04. So that will be 50 upon 4. That will be 12.5. Okay. Now we need MA. So efficiency is MA upon VR into 100%. So this is 90. This is MA. And this will be 50 upon 4. So what we do is this will be 100 into 4 upon 50. That is 2 ZA. So MA will be 90 by 8. Now since again they want the value of MA, we will have to write it in decimals. and that will be 11.25. Now we have MA is load upon effort. So you have 90 by 8, and this effort is equal to 500. So 90 into 500 upon 8, 5625 Newton. Okay, and you don't have to be so worried about the such a huge answer. It is possible because you can see that ideally it is 12.5, it is 11 times. So basically the effort is 11 times smaller than the load. This is the next question. A crowbar of length 20 meters is used as a machine to lift a box of 100 kgf by placing a fulcrum at a distance of 0.1 meter from the block. Okay, so again, like the earlier question, when you had doubted that, so here this is 0 and this is 20 meters, and we assume that the load to be over here, and that is 100 kgf, and this is the fulcrum, which is at 0.1 meter. Okay, so let me write down the load is 100 kgf, the load arm is equal to 0.1 meter, and the effort arm. Okay, now this is a little, it's going to be a little complicated because that will be 19.9 meter. So mechanical advantage is effort arm upon load arm, and that is 19.9 upon 0.1, that is 199. Okay, now VR is also 199, and the assumption is the efficiency to be 100%, and therefore MA is equal to VR. Okay, and the third thing they're asking us for the effort. So MA is load upon effort. So effort is load upon MA, and the load is 100, and this is 199. Okay, of course, you will not be tested on such difficult calculations, but these are just questions to help you understand. So this is 0.5 kgf. Don't forget to write the same unit as this. Now, a person is carrying a load of 25 kgf suspended from a wooden staff, such that the load projects 8 centimeter from the shoulder. Where should the person apply an effort of 7.5 kgf so as to balance the staff? This is a class 1 lever. Okay, so when you talk about a person, and these are the shoulders, so he's holding a staff. That means there is a stick on his shoulder. So therefore his shoulder will act like the fulcrum, and this length of the stick is 8 centimeters, and here at one end is the load acting, that is 25 kgf, and obviously he will hold the stick on this side and apply an effort of 7.5 kg. The question that they are asking is how far where he should hold it. So this is what is the question. So what we are doing is that will be the effort arm again. So let me write down this. The load arm is equal to 8 centimeter. Load is 25 kgf. Effort is 7.5 kgf, and they are asking for the effort arm. So again, load into load arm, and that is 25 into 8 is equal to this 7.5 into effort arm. So therefore, effort arm is equal to 25 into 8 upon 7.5. It is 26.67 centimeter. Okay, so this should be the effort arm. So you should apply an effort to balance the staff at this distance.